Hello! Today I will be going over remove duplicates from sorted array. It reads, given a sorted array nums, remove the duplicates in place such that each element appears only once and returns a new length. Do not allocate extra space for another array. That's what in place would mean. That we're only manipulating the integers within the array without using a spare array. You must do this by modifying the input array in place with O1 extra memory. I'm going to skip over the clarification. You can read it if you will. I just find that I can explain better without it. I find it a little redundant. So the example input here is num's integer array. The three of the three values, the two values, which is 1 and 2, they're unique. So we return the length of the unique elements, which happens to be 2 in this case. So return 2. Okay, so we've taken a look at the problem statement and example input output. So I have my solution laid out over here, and I've got my example input array, which let's call it nums. And basically it has 4 elements, and as you may see there are 2 duplicate elements here. So what you want to do is just record the length of unique element, which is 3. Now my approach is that I'm going to have 2 pointers, first of which is the index pointer, which basically returns the length of unique characters or the unique element, and the second pointer is the pointer that is pointing at the index of array. So it's going to look at each element, and while it's looking at each element, it's going to look at the current element and compare with its next element or the adjacent element. So let's walk through the example so that we can visualize how the duplicates are being removed. So starting out, I equals to 0. I equals to 0, and I plus 1 would be 1, because 0 plus 1 is 1. So at nums of 0, we find the element 2, and at nums of 1, we find the element 3. And starting out, the index for number 2 is automatically granted 1 without even looking at the elements. Because it's a sorted array, the first element ought to be unique, so we automatically give it a value of 1 for length. That's non-negotiable. So the next element after it happens to be unique as well, which is that 2 does not equal to 3, right? Nums of I does not equal to nums of I plus 1. That's correct. 2 does not equal to 3. So when that happens, nums of I, which is our value of 3 here, the element 3, that's going to have an incrementation of 1. So index will be incremented from 1 to 2. So index is now from 1 to, oops, just want to put a clear arrow, is 2. So now I equals to 1, and 1 plus 1 is 2. So at index 1 we find the element 3, and at index 2 we find the element 3 as well. There is a duplicacy, so both elements are the same value, which is 3. So in terms of the index, there is no incrementation. Our index is still 2. Because when both elements are equal, we don't do anything. As you can see in the code, there is no condition for that. Simply we disregard it for now and go to the next element. So that's what we'll do. So I was 1 previously, now I is 2, and I plus 1 would be 3, which happens to be the last index in our array anyways. So nums of 2 would be the element 3, and nums of 3 would be the element 4. Now 3 does not equal to 4, right? Nums of I does not equal to I plus 1. So when that happens, we have to increment the index by 1. So nums of I plus 1 will be having increment of 1. So index was 2 previously, now index will be 3. And hey, we've reached the end of our problem. The output is 3, as you can see. So essentially, if you want to visualize what's happening, is basically the indexes of the unique values are simply being lined up next to each other, and we're not really removing the duplicate elements. It's sort of like if I were to just draw it out, it's basically just lining them next to each other, the unique elements, and then whatever's duplicate is just behind them. So it doesn't matter what you leave behind beyond the recorded length of the unique elements. So if you wanted to visualize that, I have it there. So it's a very inexpensive solution with a time complexity of O of 1, linear time and space complexity of O of 1. So I hope that's clear. We'll run the code on LeetCode. So I have my code here just exactly the way you've seen it. Let's submit it. And there you have it. Thank you for watching. Should you have any questions, let me know.